Alright, so last week we looked at plotting points for graphing and linear equations. We're going to look at some patterns and relationships with linear equations, and we're going to focus mostly in this section on x and y intercepts. Last week what we did is we found when we were plotting points we ended up with a lot of x and y intercepts. Okay, so they're really easy ones to find to start with, but for now that's what the focus is going to be. I talked about how there are several different ways of graphing. You need to be comfortable with them all, and you need to notice and pay attention to what method I want. Sometimes I want you to plot 3 points. Sometimes I specifically want the intercepts. Sometimes we'll use point-slope form. Sometimes we'll use slope-intercept form. All right? For now, for today, we're going to focus on x and y intercepts. All right? And we're going to look at some patterns with our, and we're also going to look at some patterns with our function notation, because I want you to see how similar functions behave. So we have function f of x. F of x equals 3x. When x is 0, that means I'm solving for f of 0. What's my y value going to be? 0. Okay? I plug in 0 for x. I get 0 for y. So I have the ordered pair 0, 0. Okay? There's my ordered pair 0, 0. All right? What's f of negative 1 going to be? Negative 3. So I have negative 1, negative 3. All right? What about f of 1? 3. Okay? So there's my first line. Right? Try and draw this as straight as I can. Now, g of x. What's g of 0 going to be? Negative 1. What's g of negative 1 going to be? Negative 4. What's g of 1 going to be? 2. What do we notice about each of these output values going from f of x to g of x? It's 1. It's 1 less. So what we can do is we can look and say, okay, well I have the same part's the same. 3 of x is f of x. So I can look at g of x as being f of x minus 1. G of x is f of x minus 1. Now let's look at graphically what that does. I have 0, negative 1, negative 1, negative 4, and 1, 2. Graphically, what does that do to my line? It shifts that entire line down 1 unit. Okay? So if I have the same x value, all of my y values shifted down 1. So it's the same as f of x, except g of x is shifted down 1. G of x is f of x shifted down 1 unit. All the points on the line are moved down 1. Okay? So g of x is f of x minus 1, so g of x is f of x shifted down 1. And we can see that mathematically. We can see that graphically. So looking at the next one. Let's make a prediction. If I have f of x is negative 4x, g of x is negative 4x minus 5, how is g of x going to relate to f of x?
It's going to be down negative.
It's going to be down 5. So I can see that g of x is f of x minus 5. So once I fill in this column for f of x, I don't have to then plug in 0 for g of x to do the whole evaluation again. I can just take whatever my values from f of x are, subtract 5, that gives you my corresponding values for g of x. So let's look at f of x. What's f of 0 going to be? 0. What's f of 1? What's f of negative 1?
4.
What's f of negative 2? Okay, so I have 0, 0, and I've got 1, negative 4, and I've got negative 1, 4, and then negative 2, 8 is going to be somewhere up here. Okay, it's off my graph, but it's somewhere up there. Okay, so then without having to plug 0 in for g of x, I can just take the 0 from my f of x column and do what? Subtract 5. I can take this negative 4 and do what? Subtract 5. I can take this positive 4 and do what? And I can take this 8 and subtract 5. And that gives me a new set of ordered pair points. Let me change the color on this so I have a different color for the line. Okay? So for g of x, I have 0, negative 5. And then I have 1, negative 9, which is going to be somewhere down here. Okay? I have negative 1, negative 1. And negative 2, 3. Right there. Okay? So there's g of x. All right? Does that match our prediction of everything shifting down 5 units? Yeah. If I look at this point, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 10, 10, 5. Okay? Everything shifted down 5 units. So g of x is f of x shifted down 5. All right? So with linear equations, when we have that same slope, we can move up and down a certain number of units. We'll have the same exact graph, the same shape, just shifted up or down depending on whether or not we're adding or subtracting a number after the variable. Okay? What we're doing here is we're also changing our y-intercept. Okay? Both of these, we changed our y-intercept. So speaking of y-intercepts, recall from last section, how do I find algebraically my y-intercept?
I have a question.
Yes.
What is it shifted?
Down 5. Algebraically, how do I find my y-intercept? We talked about this last section. X equals 0. Okay? So when our we have our y-intercept, x equals 0. All right? To find, we're going to let x equals 0. So I have y equals 2/3 0 plus 1/9. So what is y going to equal? 1/9. Okay? Now, I want to make a really important point. I want you to listen very carefully. The words that are about to come out of my mouth. The y-intercept is not 1/9. The y-intercept is the point 0, 1/9. If I ask for the y-intercept and you give me this, it's wrong. The y-intercept is the ordered pair 0, 1/9. Y-intercept and x-intercept are points, pairs. And the answer to a question asking for those values has to be an ordered pair. This is the work getting there, justifying it. We're going to let x equal 0. When x equals 0, y equals 1/9. So my ordered pair is 0, 1/9. I emphasize that a lot because that is one thing that causes frustration on a homework assignment. Because put in one, why is it wrong? Well, what's an ordered pair? You're not putting in an ordered pair. Or something that causes you to lose points on an assessment because you're not giving me ordered pair. You're giving me, this is actually a lie. Fun fact, and we'll see that later. So I have to be very clear. I want to be upfront. When I ask for an intercept, if I ask for any specific point in general, I need to have an ordered pair. Same goes for the x-intercept. I need an ordered pair. All right, so x and y-intercepts. This is the same as we talked about it last time. For our x-intercept, let y equals 0. The only difference is now we have function notation. So you could also let f of x equal 0, because f of x and y mean the same thing. So if I have an equation in function notation, if this was in function notation instead, it said f of x equals 2/3 x plus 1/9, then I would replace f of x with 0 if I wanted to find the x-intercept. Okay? To find the x-intercept.
So f of x and y are the same thing?
They are the same thing.
So f of y actually the same
Well, we don't do f of y because we don't use function notation with the y value because it's not a function, because then it would fail to verbalize. So we only use f of x to replace x, or to replace y. All right. So I could replace y with f of x, and if I wanted the x-intercept, I could get 0. Okay. And then same thing with the y-intercept, letting x equal 0. If it's in function notation, then I'm also just evaluating for f of 0. If it's in function notation, I'm evaluating the f of 0. All right? So looking at here, we want to find the intercepts and graph. So find the intercepts and graph, which means on your graph, I need to see your intercepts. Okay? You can have whatever other additional points you want, but you must include the x and the y intercepts. All right? So I'm going to let y equal what to start? 0. And that's going to give me which intercept? X-intercept. Okay? So we're looking for the x-intercept. Let y equal 0. So this becomes 4 equals x minus 3 times 0. Let y equal 0. Let's substitute y for 0. So what is x going to end up equaling? 4. So what is my x-intercept? 4, 0. 4, 0. X-intercept is 4, 0. I need that ordered pair. Now, what are we going to let x equal? 0. And that's going to solve for the y-intercept. X equals 0 gives me the y-intercept. So 4 equals 0 minus 3y. Don't need that 0. So 4 equals negative 3y. What is y going to equal? The 4 thirds, 4 over 3. So what's my y-intercept? Again, another friendly word of advice. What is negative 4 thirds in decimal notation? As a decimal. 4 thirds is a decimal. Negative 1.3333 repeating, right? I don't ever want to see repeating decimals on an assessment. Either I'm going to ask you to round, and it will say round. Say round to nearest 10 or 100 or whatever. Or if it doesn't say to round, leave it as a fraction. Okay? I don't ever want to see repeating decimals. All right? You will lose points for it. All right? Especially if I didn't ask to round. Leave it as a fraction. Okay? You can leave it as an improper fraction. You can write it as a mixed number. You could write it as negative 1 1/3. I don't care. But unless I say to round, don't ever give me a repeating decimals. Leave it as a fraction. Yes, but I don't want to do that. No, because we can't do math with that. If I used to stay as a fraction. Alright, so I had, what was my equation? 4 equals 3, oh no, I'm sorry, x minus 3y. Okay, and what were the 2 points that I need to plot? Okay, so that's my x-intercept and my y-intercept. Okay, so 4, 0, where is that going to be on my graph? 4 to the right, on my x-axis. Okay, and then my y-intercept of 0, negative 4 thirds is going to be where? Okay, so about 1 1/3 down. All right, and so I have those 2 points, my x and y-intercept. I've got 4, 0. And I've got 0, negative 4 thirds. Okay, label those so they're specific. All right, now I've got this line. Now it's really easy to make a mistake and accidentally maybe forget a negative when I should have a positive, or the other way around. So what can I do to make sure that these points are in the right line? Yeah, Yeah, third point. Pick a third point. Pick any x value that's not 0 or 4. Plug it in. Solve it. And see if it's in the right spot. So let's do 1. So let's let x equal 1. This is kind of our checkpoint. Our check point. Because it's always a good idea to have 3 to make sure everything's in line. Alright? So let x equal 1. So 4 equals 1 minus 3y. 3 equals negative 3y. Negative 1 equals y. So I have a ordered pair at 1, negative 1. If that's on my line, or at least really close to it, then I know I did everything right. We're good. 1, negative 1. That pattern, what I expect. Alright? As long as it's close, because I estimated where this point was, and also my line's not perfectly straight. Kind of drops off here a little bit. Alright? But it's close enough. Alright? So it's very likely that I got everything in the right spot. Questions, comments, concerns? Okay? And again, remember when you're graphing your lines, the line doesn't have to be perfect, but I need to know where the points are. And we need you to be very clear about where those points are to make sure everything's close enough. Okay. All right. A couple more lines. So, graph x equals negative 3 and graph y equals 3. What's different about these equations from every other one we've been dealing with?
It kind of gives you the
I have an equation.
the pair.
Say it again. Everything we've had so far is straight line. Vertical. Horizontal or vertical, because what is this equation on the left missing that we have in every other equation?
The y.
A y value. What is this one missing that we've had in every other equation? An x. Okay? So we're missing a variable in each of those. And this is the main reason why. When I ask for the x-intercept, I need an ordered pair. Because if you give me x equals a number, it's not an ordered pair. It's an equation. It's a line. Same thing for the y-intercept. If you say, oh, the y-intercept is 1/9. No, it's not. That's a line. Y equals 1/9 is a line. So, being very deliberate about your answers. Ordered pairs give me points. Equations give me lines. So x equals negative 3. Now I have nothing in here for y, which means it does not matter what y is. X will always be negative 3. So if y is 0, what's negative 3? I'm sorry, what's x? Negative 3. Y is 0, x is negative 3. If y is 5, what's x?
Negative 3.
If y is negative 2, what is x? Negative 3. So it does not matter what y is. X is always going to be negative 3. So then I get what type of a line? Vertical line. Okay? Graphing y equals 3. It doesn't matter what x is. Y will always be 3. So if x is 0, what is y? 3. If x is 5, what is y? If x is negative 3, what is y? And I end up with what type of line? Horizontal. Okay? So if I only have one variable, I'm going to have a vertical or a horizontal line. If I have two variables, then that's where I get those diagonal lines. Okay? Our normal standard equations, or our most common at least. So graphing our horizontal lines and vertical lines, x equals a constant, x equals a number. Going to be vertical. All right. Now, it says that x equals a constant is not a function. There's a couple of things I can do to reason why. Why is it not a function? How do I know that that vertical line is not going to be a function? It doesn't pass the vertical line test. I look at the graph and I see, oh, well, if I run a vertical line through the vertical line, well, I'm touching every single point. So it fails the vertical line test. It means it's not a function. Also, it doesn't matter what y is, x is always going to be the same. So that means, so here I had negative 3, 0, and negative 3, 5, and negative 3, 2. The x value repeats and keeps giving me a different y value. So x doesn't correspond with only one y value. X corresponds with all of the y values. Again, making it not a function. Horizontal lines are fine. They will be functions because each x value corresponds with only one y value. Now it all happens to be the same y value, but that's okay. Only one y, each one. So horizontal lines are going to be functions. They also pass the vertical line test. Vertical lines will not have a y-intercept unless it's on the y-axis. Okay? Because it's never going to touch the y-axis. Horizontal lines will never have an x-intercept unless it's on the x-axis. So they're going to be missing some of those points. And that's it. So our next section will cover slope of a line, and we'll continue there.